My name is Paul Frazee. I work on the Beaker browser, which is a peer-to-peer browser that uses the Hypercore protocol tech. I'm actually going to be giving 2 talks today, but my first one is going to be covering the change from the DAT protocol to the Hypercore protocol and what this means for the future of the DAT ecosystem. So rebrands like this are always complicated and confusing, and my goal with this talk is to try to clear up any confusion and leave everybody walking away with a lot of clarity about what's going on and what it all means. And so the way I've structured this talk is I'm going to start with a set of clear takeaways that I'm just going to go through one after the other, just to make sure that you know what to walk away knowing. And then I'll talk a little bit about the history and what's going to be happening in the future. So let's dive into these takeaways. Clear takeaways. Takeaway number 1, the DAT protocol is now the Hypercore protocol. So that's now what we're referring to the peer-to-peer technology as, the Hypercore protocol. DAT URLs are now hyper URLs. So we're not using the DAT URL scheme anymore. We're now using the hyper URL scheme. The Hypercore has new governance led by Matthias Boos. And DAT is now a consortium or collective or a community of projects that have come together on this technology that work with the Hypercore protocol and are interested in all things decentralization, local first, peer-to-peer. So let's give a real quick history of how we got to where we are. 2013, DAT was created by Max Ogden as a command line tool for scientists and researchers to work on tabular data. The idea was that it would be a kind of a Git for data. And that project persisted for about 3 years with some user testing, and some of the feedback they got was that scientists and researchers were really more interested in solving things like synchronizing files between devices and archiving information for posterity, their research and their publications and things like that. So in 2016, they decided to sort of pivot the project into something that was designed to help with file sync. And that's when Matthias was brought into the DAT project, and he began the Hypercore project. Now, internally, the peer-to-peer technology was always called Hypercore and Hyperdrive and so on and so forth, but we started to talk about DAT not just as a command line tool, but as a protocol, and that's when we began talking about the DAT protocol. In 2017, there was an unexpected leadership change. Max Ogden left the DAT project, and it was a slightly tumultuous time where to step up to get us through that period. And notably, Daniel Robinson, Carissa McKelvey, and Joe Hand really stepped up in the leadership roles in that period. And then in 2019, the DAT project was renamed to the DAT Foundation. So from 2013 to roughly 2018, 2019, we were funding the work on the DAT protocol through grants from a number of organizations, the Knight Foundation, the Alfred P. Sloan Foundation, Mozilla Samsung Handshake. Big thanks to all of those funders for helping keep this work alive. But by 2019, a lot of the development of the protocol had moved out into separate organizations. The protocol development was no longer, Matthias was not a part of the DAT Foundation anymore. A lot of the work was really being done by a collective of organizations working together. And so in the beginning of 2018, we put together what we called the DAT Working Group. And that was a collection of 7 individuals from different organizations working together on DAT. And that has a nice, probably year, maybe year and a half of lifetime, but by the time we reached present day, really only 2 of the original members were still involved, so we needed a refresh on the governance for the DAT protocol. Another thing that happened, particularly in 2019, is that we went heads down on protocol refactors. Hypercore was started in 2016, so we'd had a few years of working with the protocol, seeing how it performed, seeing what worked and what didn't. And we basically accumulated a laundry list of things that, as you would expect for a new protocol, needed a little bit of work. So here are some of the high-level things that we were focusing on. The first one being read performance at scale. We started to realize that DAT archives were starting to slow down in their reads once you started to hit a certain size. It was kind of, as the DAT archive had more writes to it, we started to hit some scaling problems. We had a couple of problems with connection reliability, just not being able to find peers. We were using a centralized tracker that we were running, and that's no good. We wanted to move to a distributed tracker, so that was a part of what needed to change. We were finding a lot of people were using the core pieces of the DAT protocol as opposed to the files approach that we initially had started with the DAT protocol. So people were really using Hypercore almost right from the get-go. And the way that the protocol was designed, it needed a little bit more flexibility to make that possible for people. And then we also had the focus on multi-writer. That was a big part of what was worked on in 2019, still an ongoing story, but that was a major portion of what was being experimented with during the 2019 sort of heads down period. So after a lot of hard work by everybody involved, a lot of this stuff really made some leaps and bounds, and read performance in particular really improved a lot thanks to the change to the Hypertry data structure. We got the DHT with Hyperswarm. Connection reliability became much more reliable when we moved to Hyperswarm, and so on and so forth. But these changes involved the dreaded breaking changes. And so at this stage, we were looking at the need to refresh the governance, the fact that the different organizations were being involved in the project as opposed to the DAT Foundation being the sole developer of the technology, and these breaking changes, and we decided it would be a good idea to go ahead and start fresh with the technology. And so we decided to rebrand it to the Hypercore protocol. And so that's how we came to where we are right now. So a little bit about what changed there. We have now the hyper URLs, which are actually similar to before. They use 64-character hex keys to identify the Hypercore data structure that you're referencing. Probably the biggest difference in this URL scheme is that they now can describe any kind of Hypercore data. In fact, Hypercores are self-describing. They include a header where they say what the data structure is. And so a hyper URL does not always mean a files archive like it did previously. It can now mean things like a key value database or a log of information or many other things, anything that you could represent with Hypercore. Here are a collection of some of the, I thought I changed that slide. Well, here's a collection of some of the data structures that we currently use with Hypercore. You have Hyperdrive, which is the files archive. You have Hypertry, which is a key value database with a kind of a pathing structure. There's Kappacore, which uses the Hypercore logs to form materialized views. If you are familiar with the Kappa architecture, that's what that's based on. And there are many more people working, just off the top of my head, Cabal, Sonar are two projects, probably Pure Maps, leveraging Hypercores to build custom data structures. So a lot more data structure flexibility is a big part of the recent change. One side note is that what we previously called DAT archives are now called hyperdrives. So that's a part of the semantic change that's occurring here. And as an interesting sort of side note, hyperdrives are actually built on top of hypertries. That's where I fixed that slide. All right. Okay, so DAT and the DAT protocol are now legacy. We're not going to be using the DAT URLs anymore. A couple of the different clients will continue to support DAT. For instance, Speaker has it in a sort of a read-only legacy mode. But the idea is that we're now going to be moving entirely to Hypercore protocol and the hyper URLs. That said, DAT lives on as a community, which is exactly why we're all here today. A number of projects that have been created over the past years using the Hypercore protocol technology and really just by the association of the people that are all involved to know each other, and we wanted to continue this community along with the rebrand. And so the way we decided to approach that is to continue to this community of projects. And so it's currently called the DAT Consortium. We're still actually choosing the name for this. It might be the DAT Collective or something like that. But this is still an active community. We meet twice a month. We work to fund projects and also fund events, such as the one that we're having right now. And a big thanks to the organizers for making this happen. That came directly out of this consortium. And then a major portion of what the consortium or collective is designed to do is to facilitate communication between the projects. So we can keep each other up to date on what we're doing and also stay abreast of updates to the Hypercore technology. So that is my short, concise overview of the changes from the DAT protocol to the Hypercore protocol and the future of the DAT ecosystem. I hope this has helped give some clarity to the big changes that have occurred, and I look forward to the future of working with this community. So thank you all very, very much for listening, and I suppose we probably have time for Q&A. It's a pretty quick talk, so if anybody has any questions, I'm happy to answer them. For posterity purposes, I'm now staring at the chat to see the questions. Okay, there's a question, is there a master list of renames? I don't think we do have something like that. It would be a good idea that we just put together gist or a README file somewhere, just kind of doing arrows pointing between the different names. But broadly speaking, probably there's really three things that I think had a notable rename: the DAT protocol to the Hypercore protocol, the DAT URL to the Hyper URL, and the DAT archive to Hyperdrive. Those are really as far as I know, the only sort of forward-facing or outward-facing names that got changed. If anybody can think of others in the chat, feel free to. How can outsiders join the DAT consortium? Martin, you are asking. Martin's a part of the consortium, so actually, I believe we're still working on a process for all this. You know, the consortium is still sort of finding its feet and self-determining, and so we're figuring out how the consortium is going to be governed, what the process is for people coming into it, and things like that. So keep an eye out. I'm sure that we will be talking publicly about how all this is going to be structured over time. You'll have to ask Matthias where hyper comes from. I don't personally know, but it came by. Oh, I'm sorry. Yeah, Martin, what's up?
I'm looking if Matthias in the chat. We can enable his mic if he wants to.
Our apps tool based on DAT now deprecated the DAT desktop and the DAT CLI. Yeah, so that's a sort of an ongoing question. I believe DAT desktop is deprecated, and the DAT CLI is looking for a maintainer right now. So the future of those projects are still indeterminate. I know that a lot of work is being done to more or less replace the function of those things. As to whether or not those tools will continue, that's still figuring that out. Are there any things that remain to be moved from DAT to the new hyperstructure? I think we've moved pretty much everything, so I don't think there's anything still waiting on a move. Files is files. Matthias gave his answer for where the hyper prefix comes from. He says it's a fun name by itself, and it's always the thing that fails in Star Wars. So that's where the Hyperdrive came from. Any news on the DNS link that the DAT protocol had? Yeah, so previously the DAT protocol had a solution for DNS that was using TXT records and also a .well-known record on HTTPS sites to do DNS. There's no news on that yet. There's been some interest in bringing that back, and you know, we're thinking about it. We also wanted to explore if there was a new way we could do DNS for the Hyper ecosystem, but you know, DNS is complicated. It's more than just a technical thing. The ideas that have been floating around for Hyper DNS are pretty fantastic on a technical level, but then there's the sort of organizational question of how do you avoid creating an organization which monopolizes the domain namespace. You don't want to just have one org that you register with, and so you sort of have to intentionally avoid creating a monopoly and force a market to exist. You want to get things like registrars involved. So we're still figuring out whether or not it's possible to create something that's a better DNS, and in the meantime, we may end up bringing back the DNS link. I know that people would like to have short names, and so, yeah, that's sort of an ongoing discussion right now. Does a Hyperdrive save the history of the file system similar to a DAT archive, and if so, would many small changes to a large file system impact the overall size of Hyperdrive? Yeah, the internal structure of a Hyperdrive is similar to a DAT archive. They're all using these append-only logs, the hypercores, so the history is being recorded in that way. We're planning to introduce a way to tag points in the history of a Hyperdrive to say that this is a snapshot that you want to keep and perhaps don't keep the rest of it, and that will help avoid that problem of the space growing out. So there's no reason that we can't delete the prior history on a technical level. It's just a matter of engineering to get done. So at the moment, yeah, you're going to have, if you do a lot of small changes to a Hyperdrive, it's going to grow in size. But eventually there will be updates to the various clients that will help clear out that history and keep things lean. Carl, I take issue with the phrasing of this question. Will there be a GUI for managing hyperdrives like DAT desktop that is a little more user-friendly and less bloated than Beaker? I'll try not to take that one personally. Yeah, I mean, I think there probably will be something like that showing up at some time. I don't know if there's anything I can definitively say yet, but I know that there's interest in having something like that. And of course, because the daemon is one of the nice updates that's occurred since with this rebrand is that we have demonized the tool set. So having multiple applications that share the same data set that use the same daemon are now possible, and so having small applications that work in addition to any other hyper applications that you're using side by side will now be much easier to do. Somebody can get that diet beaker done. All right. Is the focus still on science and science data for the community, or is the vision now broader? I think the vision is broader now. There has been a lot of different projects that have all sorts of different focuses from, of course, the web browser projects like Beaker, Agrigor, and the Gateway browser, which is a mobile hyperspace browser. And so there's a lot of web use cases there. There are things like Cabal, which is like a Slack competitor. There's Pure Maps, which is synchronizing map data. And so the science and science data is really not what I would call the focus of the technology, but it is certainly a good enabler for projects that are focused on science and science data. So the vision for the community is broader, but projects are, I think there's something Liberate Science, I think, is maybe one that's really focused on that, that's in our ecosystem. Adil asks, is Hashbase also deprecated, or is there a plan to migrate it to support Hyper? So Hashbase is going to continue to exist as a DAT protocol host. My plan is to just go ahead and keep it running, and it'll just exist as a legacy project, just to kind of make things easier, keep things stable there. And we're going to start a new service Hypercore. It'll have a different brand, different URL, and so on and so forth. It'll just be completely separated. But I figure that'll be the easiest way for us to get that done and move forward. So Hashbase is going to stay as it is, so if you're relying on it now, you can continue to do so, and then we'll have a new service for the Hypercore protocol. There's a Liberate Science talk also, so I guess that's going to be coming up. I got a question in IRC, so let me try to reach that real fast. Kira asked, side question, where do hypercores and Hyperdrive Hypertry self-describe themselves? Is this like in the first metadata entry or something else? I do believe it's in the first entry in the Hypercore. You'll have to ask, that's a question for Matthias. I'm not personally.
Can you repeat the question, Paul?
Yeah, so I mentioned that Hypercore data structures are self-describing. They have some kind of a header where they identify what the data structure is. Can you comment on where that is?
Yeah, so it's actually following an old spec we made. We should make sure to migrate over. It's I'll find the exact one in a second, but it's this spec where the first message in the Hypercore follows a port buff schema, where you can add a string name for your data structure and some metadata. The metadata we add in Hyperdrive is the content feed key.
Yeah. Johan says Windows support for Hyperdrives is limited because of Fuse Drive. What can we do to help make it available on Windows? Well, I don't know the answer to the question about how to make that work on Windows, because that's a deep dive project for somebody. Martin suggests WebDAV. That's an interesting proposal.
There's a PR, actually, not a PR. There's a developer who's very active on that on our Fuse driver.
Really?
Who has it working? He says using Windows WinFSP. But what we really need, because we can't just let's say we got a PR. We need somebody. It would be great to have somebody, if somebody's interested, to help lead that effort.
A champion.
So we can also maintain it and make sure bug fixes and stuff like that. So if you're interested in helping with that out, there's an issue going on the Fuse Friends repo organization, Fuse-Friends on GitHub. But it really needs just more maintainers, so we can get proper support for it. But it should be possible.
Yeah. So Martin just asked, how can somebody become a champion for something like that? what Matthias said. You find that issue and talk to Matthias, and basically what you'd be signing up to do is to really make it your project, something that you're going to be responsible for, and so you just need to communicate with the protocol team that you are willing to take on that responsibility and give assurances that you will, and I'm sure that they figure it out that way.
Matthias just shared an issue in the chat where you can look up more about views.
I also heard somebody say that you could get it to work through that Linux subsystem on Windows now, but I don't know much about Windows, so that's why it needs that champion to work.
Windows is that platform that you think, hey, nobody uses Windows, right? And then you look at your analytics and go, oh my gosh. Lots of people use Windows. Vox Pelly asks, is Beaker going to interact with non-Hyperdrive hypercores? It is. That is on our near-term roadmap. Near-term being a relative term, but yeah, we fully intend to do that. Very interesting to talk about how to handle the different data structures that show up there. If it's a data structure that Beaker doesn't recognize, what does it render whenever that shows up? That's an interesting question. Might it be possible to have different applications register as handlers for different data structures? Also an interesting question. The first thing that'll happen, I'm quite sure, is that there'll just be API support for it, so that applications can start to leverage it directly. And the really exciting thing about having Hypercore as an API available is that you can begin to build custom data structures, which I think is particularly interesting when it comes to database technology, things like indexing. There's some initial work going on things like a B-tree implementation on top of Hypercore. And so you can start to have ordered key value databases and use that as a, one of the things I'm keenly interested to do is use that to produce secondary indexes. So you crawl a bunch of Hyperdrive websites that start to store your crawled index on these Hypercore-based data structures using this API, and now you're able to publish your secondary indexes, so you can do distributed search. So it's a really interesting technology to be integrating into this thing. And so initially it'll be largely through the Hypercore API, and then we will sort of sort out what happens when you visit these things over time. Okay. So James says, I have listened to Matthias talk about real-time being a specific differentiator over, for instance, IPFS. Is this seen as a key message for Hyper? I feel like that usually just comes up when somebody asks us what the difference is between IPFS and Hypercore. What he's referring to there is that IPFS is designed specifically for content hash-based blobs of data. So the idea being that you're going to calculate a fixed hash on a static piece of content and then sync that out to the network, which has a lot of nice properties, one of them being that there's no implied ownership over a content hash. So if there's some piece of information which sort of is collectively used quite a bit, it's just this sort of detached from any notion of authorship. It's just so the ecosystem staying alive. So the content hash approach is really an interesting approach to building a global database like these protocols are. The Hypercore use case is focused on the idea that there is an author and they are appending to a log of data. And so whenever you want to make a change to the data, you don't actually have to hit the DHT again to find the new blob or anything like that. It actually is just something that can occur in network where you're just appending to the existing data set. So you can stream the updates over an existing connection without any confusion. I can't speak to whether or not IPFS is able to do something like that. As the longer these projects mature, the less these differences will probably matter. But real-time data is definitely a key focus of the Hypercore protocol. Also, efficient read access is a really important goal of this thing. We're, for instance, using in these various web browser projects, we're using hyperdrives as websites. And one of the things you expect is to be able to click on a URL and have the thing load up pretty quickly. So having really, really efficient peer-to-peer read times is a really key factor in the design of the technology and a key focus, which is why a lot of the work that was done in 2019 on Hyperdrive was done, so that you can take any given file inside of a Hyperdrive. You don't have to sync down all the data. You can sync down exactly the data you need and pull up the website or the set of files as quickly as possible. And so in many ways, I tend to think of the efficient random reads as being actually one of the really key things about this in the spectrum of peer-to-peer technology. Speaking more broadly, I think that the way I'm inclined to message the Hypercore protocol is as a sort of a global. Alexander says the biggest difference is the community. I'm sure we could duke it out with the IPFS, but I like the sentiment. One of the things I think that is a key message for the Hypercore protocol is this idea of introducing a database layer to the internet. The internet for so long has been a connections-based system. There's never been a sort of a global database layer for the internet. And by having this global database protocol, we opened up local first computation and this idea that information could be published from any device, which is really a key notion for a lot of the projects which are focused on decentralization, local first, personal computing, but on a global scale.
Just a note from the moderation, we reached the regular time of the talk, but we can have 5 or 10 minutes more if you need it.
I'm fine hanging out just to see if there are any more questions. When you say any device, what are the constraints on smartphones? Yeah, so the constraints, it's an interesting situation. Hypercore protocol, the main kind of headline of the technology is what I'd call topological flexibility. All right, so you can have basically any device in an ad hoc fashion begin to serve information. And that means that you're no longer bound to things like services. What that ends up meaning in a practical sense is that your constraints devolve into the constraints of the actual device. How much disk space does it have? Does battery life factor in? CPU power, RAM, things like that. And so smartphones are, as powerful as they are as devices, it'll be interesting to see exactly how far you can go with them. Things like battery life are a pretty big deal. If you are looking to host lots of data off of a smartphone, you're going to have to keep the thing active and running and serving the information. And so without some tight integration to the underlying primitives of the operating system on the mobile phone, you may end up draining that battery life or using up your data really quickly. So it's entirely possible that what will happen is for smartphones, we may find that they have to act as in a very thin mode, which is not it's still using the same technology, but the sort of thing where maybe they only keep the very most recent versions of the data and they only connect to one node that they have configured and then sync their data out that way. And so they're still participating directly with the Hyper ecosystem using the underlying technology, but they're acting as sort of the most reduced mode possible in order to deal with the constraints of the device. I'm speculating on that. It really depends on how effective the smartphones are for dealing with the resource requirements of the technology. In terms of the actual capacity of those platforms to run the technology, I think a lot of people know currently Hypercore protocol is built on Node.js, and there's a Rust work being done, which is I think the next talk talking about that. But yes, that's. It appears Calm Red has actually been able to get both Android and iOS able to run the current Hypercore implementation, and it seems to be working pretty well. So yeah, I think he's doing that with React Native, I believe, is how he's powering that. And so in terms of just basic compatibility with the devices, we seem to be able to work. Couple of things that are still interesting questions about that, like, I don't think there's going to be any kind of daemon system in that. So, if you have multiple applications on your smartphone, I don't know if they'll be able to share data and things like that. So that's sort of an interesting question. And ultimately, the ideal future, I think, mobile phones would begin to integrate this technology natively into the operating system, but that's real far forward looking. What is the status of the Hyper URI standardization? We actually are in the IANA registry, thanks to some help. I'll gosh, I can't remember who that was now that helped us out with that, but we actually are listed as a URL. We have a very simple spec demonstrating how that works. Is there any way or plan to allow the version tag to be a hash instead of a sequence number to gain the same not modified guarantee that IPFS gives? We have a unadopted but sort of work in progress spec for that. We call them strong links. It's certainly something that I think people are interested in. We just haven't gotten to that yet. How well suited are the Hypercore protocol today for server use, like a server crawler that wants to index web pages as well as content in hyperdrives, like Web mentioned? I have been doing a little bit of experimenting on that and found that it works pretty well, actually. I was using an early beta of Hyperspace. I haven't put it through major paces, but I set up a couple of services, one of them doing basic rehosting, another one is actually doing crawling. And those services have, they're just small nodes on Google Cloud, and they haven't started to throw up red warning lights yet. I haven't even bothered looking at them, so they seem to be doing pretty well. I think the server stack is actually going to be pretty great with the Hyperspace update, and I actually love that space of use cases for this, because that's where you can start to do interesting data aggregation projects. And so I think now is a great time to begin to look into using Hyperspace on the server. The current design of Hyper exposes the IP addresses of all peers. This is due to a design / unavoidable due to the stack. Yeah, I mean, what we're dealing with, this is actually something that's been talked about a lot recently. I blogged about it on my Hyperdrive profile recently. Basically, whenever you access any Hypercore, you're going to have to hit the DHT to look up peers. And if you're looking to host the data, you're going to announce yourself in that listing of peers. Now, that listing doesn't reveal what the information is. We use a hashed key to sort of obscure what the information is. So if somebody were passively watching the network, they wouldn't know what you're syncing. But if they had the Hypercore's URL, if they had the actual key, they'd be able to access the data and see what it is. So the URLs sort of act like share links in like Google Docs, a secret share link. So that said, there's still a lot of metadata getting leaked there. You can see the listing of IPs on the DHT, so you can see, for instance, if two people are in communication, probably it would be too hard to track that sort of thing. And to solve that, you're really going to need one of two solutions. You're either going to need a traditional proxy or a distributed proxy. And the distributed proxies would be things like I2P and Tor. Ultimately, the decision between those two, there are trade-offs on both. Distributed proxies have questions about efficiency, and right now we're in a period where we're working hard to get the read performance really good for Hypercore, and so introducing additional networking inefficiency through something like Tor and I2P is not something we're keen to do at this stage. So we're going to have to revisit that question of using a distributed proxy once we've sort of hit our performance goals for a Hypercore protocol fundamentally. And so in a lot of ways, it seems like a traditional proxy solution would be the most efficient choice, and in fact would probably in some ways give a speed increase, because the traditional proxy would be able to take advantage of the fact that it is tracking a lot of connections, and so could arrange them probably pretty quickly. So that's still an open question. There's nothing that's been solidified on that. And like I said, there are trade-offs on both solutions. Of course, a traditional proxy is still a single party that's able to monitor the metadata of these connections. That's an improvement, but it's not perfect. So open conversation that we take seriously. We're thinking about it, but it's just going to take a little bit of work. Are any of us participating in the upcoming named data networking meeting? I don't believe that. Oh, I certainly don't know anybody off the top of my head. If anybody in the chat wants to chime in, feel free. But yeah, I don't know of anybody. Was there any recent work in protocol land for metadata resistant changes? I remember that. Yeah, Sarah, Jamie Lewis roasted us on that one. No, nothing new to report. I gave, what I just said about the options about proxies, whether distributed or traditional, is pretty much where we left off.
So to getting to an end slowly. Last question that I was asking in the chat. Where can we follow the progress of the .dot ecosystem and the progress of Hyper, and how do we do that best? Is it in the chat or Twitter, or how do we get there?
So I'll give the answer, my personal answer, and then if anybody has additional suggestions, feel free. But they probably the best way I think right now is actually to get into the Discord, which I think that's So if you go to chat.hypercore-protocol.org, which is the link that Matthias recently shared in the chat, that'll take you there. That's sort of an invite link to get into the Discord. So that's probably one of the best ways to stay abreast of things. Follow the projects on the Hypercore protocol GitHub. That's another great way to do it. And then I believe the @dat_protocol is still going to be active, keeping things updated. I don't know if we're going to rename that Twitter account or not, but that's probably one of the best ways to keep abreast of ecosystem things. So those are the three I would recommend: the Hypercore protocol Discord, the following the projects on GitHub, and and the DAT protocol Twitter. Why no love for IRC? We did IRC for a long time. It still has a soft spot in my heart, but Discord is really doing pretty good these days. Yeah, we are also on Freenode under #DAT, and also there's #Beaker, #Beaker browser specifically. But so that is still active if you're interested in joining those channels on IRC.